And it will take a minute for the Open Galaxy site to come up. Just give it time. There it is. It says it's establishing the desktop. All right. Here is what the desktop looks like. If you're coming to the desktop for the first time, you won't see this project manager here, so you'll just get a big blank screen. Down at the bottom of it, down here, and the bottom left-hand corner, it says Start Here. That's where you would want to click on if you've arrived here for the first time, and that's what brings up this project manager. The project manager is where you find everything that you need to do for the system. And if you give me a second, I need to find my presentation again, which was somewhere. Can I move this over?
Shall I bring it over?
Yeah, if you can. I seem to have difficulty moving this screen around. There's too much lag on my end.
You want to put it at the right side?
Yes, please.
Okay. Yes.
Right side, left side. Yeah, okay. All right, so right, so this is where we got to. We opened the Open Galaxy Project Manager, and from here you can see the project. If you click on the project, then you have the ability to run any of these things on it, which is the schematic, the layout, the LVS, and characterize. Characterize is the one I'm interested in. I will show you really briefly. If I say edit schematic, then it will bring up the electric schematic editor. That from there you should see it says the demo schematic is right there. Double click on that and you'll see there's the symbol, the same symbol that was up on the web page, and here it's connected into the outside world with a number of pins. So that's really what the demo is. It's just the symbol and surrounded by pins. But what that allows you to do is it allows you to run this characterization. So now if you click on characterize, this brings up what we call the characterization tool. And you'll immediately see that it looks very much like the web page view in the IP catalog, and that it's got all these different things, the VOL, VOH, TPD. Now, if you want to see how we characterize it, you could potentially, and I don't want you to do this right now, click on Simulate All, and we'll go through the whole thing and simulate every single parameter and give you a full data sheet that's the same as what shows up in the web-based catalog. Just to give you a taste of what this does, if you'll go to, let's take a look at the propagation delay through this. So here we have Simulate. Click on Simulate, and that will bring a pop-down menu. Instead of saying run here, which would run a whole bunch of different simulations that would characterize it and find minimum, maximum, typical, let's do a copy. What that does is that gives me my own copy of this simulation of this electrical parameter. And then once I have my own copy, I can say edit. And that gives me all the list of conditions under which this thing is being simulated. What this characterization engine does is it goes and looks at all the conditions that I have declared for this electrical parameter and combines them. So it says, okay, I need to look at temperature from -40 to 85 as it has been declared here. So in steps of 20, so it'll run simulations from -40 to 85 in steps of 20. It'll also run simulations over all these corners, worst case speed, worst case power, and typical. So what I want to do now is reduce the number of simulations, so I only have to get it to do one. So let's remove worst case speed, worst case power. So now it's only going to characterize the typical. For temperature, let's remove the stepping so it doesn't step. And remember, I said you could look at things that are above and beyond what was characterized. So let's see what it does at 110. So I'm going to click on a temperature. I'm going to type in 110 here for the temperature. And so it's now going to do a single simulation that is at the typical corner and 110 degrees. So I'll click apply. So now that's set the conditions under which this parameter is simulated. I'm going to click close to pop down that window. And now I can run simulate and run. And it should go through a single simulation. The first time it runs the simulation is going to take a little longer because it's creating the net list from the schematic. So it'll take a few seconds to generate the net list. And then you should see, there we go. Now you see ngSpice running. And since it was only doing one simulation, it ran pretty fast and gave me a result which is a single value. So what it was at typical corner and 110 degrees is 1.4 nanoseconds rise time. So, and of course it's the same minimum, maximum, typical because I just did one simulation. If I'd done over all temperatures, it would show me the minimum, maximum, typical over all temperatures. And that's how we do the characterization. So this is probably a long-winded way of saying this is how you can trust the IP blocks that are in the IP catalog. They've been characterized. What you see in the data sheets in the catalog is what we've done to show that these IP are what they say they are and that they behave the way you would expect them to behave. And if you want to see whether they behave in a different way under different conditions, then you can go get a demo of that and test it under whatever conditions you like. So that's all I really wanted to show for the characterization tool. So I'm going to close that down now.
Let's take a couple of questions here, Tim.
Yeah, I think this is a good time for questions.
Okay, just a minute. I'll just take back the control from you.
Sure, go ahead.